Honorable students, good morning. This class is for the students of Inter Math 11th class. The medium is English. This class is for the board exam, and after completion of board exam, we will discuss critical problems for the competition as IIT, JEE, Main Advance, NDA and others. In this video, we will discuss how we obtain the limiting value of the function for all the forms of indeterminate forms. One by one, by giving example, we will discuss the method of obtaining limiting value of the function for several forms, for several indeterminate forms by giving an example. Let us start. First, 0 by 0 form. There is two methods for obtaining the limiting value of the function for this indeterminate form. First, division method. Division method. Second, differential method. Differential method. First, division method. Division method. As we know that the function takes this form 0 by 0 when the function is in fractional form. If the function if the function takes this form 0 by 0 for x is equal to a, then there must be a common factor in numerator and denominator of the function which becomes 0 by 0 for x is equal to a, which becomes 0 for x is equal to a. If, I repeat again, attention please, if the function takes the form 0 by 0 for x is equal to a, then there must be a common factor between numerator and denominator of the function which becomes 0 for x is equal to a. We remove this common factor from the numerator and denominator, and then putting the value of the variable x a, we get the limiting value of the function. This will clear by an example. Let us see. Evaluate limit x tends to 1, x square minus 4x plus 3, x square minus 5x plus 4. Here we factorize numerator and denominator. by splitting middle terms. We know this. What we see here? Here we see at x equal to 0, the function takes the form x the form 0 by 0 at x equal to 0, at x equal to 1, at x is equal to 1, the function takes the form 0 by 0. Now we obtain the limiting value of the function. How? We split numerator and denominator. We factorize numerator and denominator by splitting middle terms. Let us see. I write here. Limit x tends to 1, x square minus 4x plus 3 by x square minus 5x plus 4. This is equal to limit x tends to 1, x square minus 3x minus x plus 3 by x square minus 4x minus x plus 4. This is equal to limit x tends to 1, x minus 3 minus 1, x minus 3 by x minus 4 minus 1, x minus 4 बराबर is equal to limit x tends to 1, x minus 1, x minus 3, x minus 1, x minus 4. What we see here? Here there is a common factor x minus 1 which becomes 0 for x equal to 1. What we see here? Numerator and denominator. X minus 1 is a common factor which becomes 0 for x equal to 1. We remove it. Then what it becomes?
T.
Now we remove this common factor. This is equal to limit x tends to 1, x minus 3, x minus 4. What we see? Indeterminate form does not exist here. Indeterminate form, abolition. Now we put x equal to 1, the value of the variable x equal to 1, we get the limiting value of the function. Let us see. This is equal to 1 minus 3, 1 minus 4 is equal to minus 2 by minus 3. This is equal to 2 by 3. This is the required value of this is the required limiting value of this function. You should note it as notebook. Now second method, differential method, I will discuss by an example. Let us see. B. Differential method. Differential method. We know that, as I have told you, the function takes the form 0 by 0 when the function is in fractional form. But if the numerator and denominator of the function are in logarithmic or exponential form, then we use differential method for obtaining the limiting value of the function. If the function takes the form 0 by 0 for x equal to a, then what we do? We put x is equal to a plus h in the function, and then we expand both numerator and denominator. But in this situation, what we obtain? We will get a common factor in the power of h between the numerator and denominator. We remove it, and then we put h is equal to 0 in the function. We obtain the limiting value of the function. I repeat again. Attention please. As we know, as before I have told you, the function takes this indeterminate form when the function is in fractional form. But when the numerator and denominator are in logarithmic or exponential form, then we use differential method for obtaining the limiting value of the function. If the function takes the form 0 by 0 for x is equal to a, then we put x is equal to a plus h in the function and expand both numerator and denominator. Then we get a common factor between numerator and denominator in the power of h. We remove it, this common factor, and then we put h is equal to 0 in the function, and we get limiting value of the function. This will clear by an example. Let us see. Evaluate limit x tends to 2 log x minus 1 by x minus 2. Here see, where you see at x equal to 2, the function takes the form takes the form 0 by 0. Then limit is equal to limit x tends to 2 log x minus 1 by x minus 2. This is equal to log 2 plus h minus 1, 2 plus h minus 2, limit h tends to 0. Put in x equal to h plus 2, h plus 2. In this case, what we h tends to 0 when x tends to 2. When we put x equal to h plus 2, h tends to 0 when x tends to 2. So the function takes this form. Now further, here you see limit h tends to 0 log 1 plus h by h. Now we expand this. I write it here above. We expand it. Limit h tends to 0, h minus half h square plus 1 by 3 h cube minus and so on by h. This is equal to this. The formula for the expansion I will discuss later. How this has this takes this form. This is we have all read in logarithmic series in algebra, and I will also discuss further. Here I have written it. Here I have written it. Now we take common h. H tends to 0. We take out h common. 1 minus half h plus 1 by 3 h square minus so on by h. Here this is common factor between numerator and denominator in the power of h. We remove it. Limit h tends to 0. 1 minus half h plus 1 by 3 h square minus dot 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 and so on. Now what we see? An indeterminate form abolishes. Now we put h is equal to 0 in the function. We get limiting value of the function. This is equal to 1. This is the required limiting value of the function. In the next video, I will discuss other forms of the function. I will taught how we will obtain the limiting value of the function in the case of different forms, different indeterminate forms of the function. You should note it as notebook. Please like, share and subscribe my YouTube channel Mathematics Vibes. I Satish Kumar Thakur, lecturer in math, Rajaram Shah College, Raxaul, Bihar, India. Have a nice day. Thank you.